I'd like to begin by asking everyone to please take a deep breath with me. In and out. Great. We all just collectively respirated about 25 gallons of air. The American Lung Association says that, on average, a person breathes about 2,000 gallons of air per day. Now, imagine if some of those 2,000 gallons were made up of harmful gases or were carrying tiny particles that stuck deep in your lungs. For an estimated 90% of the world's population, breathing polluted air is a daily reality, and this can have some serious health effects. In fact, exposure to air pollution is the #1 environmental risk factor leading to death and disease around the world. Clearly, this is a problem that we need to address. But before we can clean up our air, we need to better understand just where in the world all this pollution is coming from and how much of it we humans are emitting. Those can be difficult questions to answer, but fortunately, there are some tools to help us out. In my research, 2 tools help us answer this question. The first is a computer model of air quality. The model simulates the atmosphere in 3D. It connects the sources of air pollution to their impacts, and it's used by scientists and policymakers to help regulate air quality. In order for this model to produce meaningful results, it needs to know all of the pollution being emitted around the entire world, but that's nearly impossible to actually know. And inevitably, there are gaps in the emissions data. That's where the second tool comes in, a NASA satellite. This satellite is orbiting the Earth right now, measuring the amount of a pollutant called nitrogen dioxide, or NO2, which is emitted primarily from human activities like driving your car or operating a power plant. NO2's short chemical lifetime and human-caused nature make it the perfect candidate for mapping and estimating air pollution emissions. And I use that data to create a map that's up on the screen. In order to fill in those gaps in the emissions data, I use a method called data assimilation to combine the air quality model with the satellite observations. In this approach, the satellite observations nudge the air quality model a little bit closer to what the satellite actually observed. Then, based on the size of that change and where on the map it's occurring, I can see where we are missing emissions information, and I can go back and fill in the gaps. As a result, not only does this process update the emissions information that we need to better understand the air pollution problem, but it can improve the model's ability to simulate the impacts of air pollution. The air that we've been breathing today could contain pollutants from around the world. My research helps us better understand where that pollution is coming from. In doing so, it can help policymakers make better decisions about regulating air quality, and hopefully that can get us one step closer to cleaner air for everyone. Thank you.